Hi everyone, my name is Hao Li. I'm the CEO of Pinscreen, that's a startup here right in Santa Monica. I'm also a professor at USC and also the director of the Vision and Graphics Lab at the USC Institute for Creative Technologies. All right, so the talk today is about AI and human digitization. It's not really how do we create avatars that have an AI mind, but it's how do we use AI to generate these avatars. So first of all, why do we care about this? Well, I believe that someday we're going to connect very deeply with 3D avatars and virtual humans, and some of them will be equipped with some form of artificial intelligence. If not, it has somehow already happened. And one of the, when you're doing a startup, you have to think about practical things like where things are going. And virtual assistants is a practical things that we'd like to have, right? So imagine if you would be buying stuff on Amazon from Jeff Bezos in person. That would be a funny thing to have. On the other hand, we're also focusing on very specific applications where it's not only about the avatar itself, but imagine if you can actually digitize yourself in a photorealistic way, you can simulate certain things in a, very conveniently. So imagine if you have the problem of the fitting room problem. So one way to solve this is that instead of like going to the store, trying out yourself, you can actually do it from the comfort of your home if you had an app that can do that. So that's what our Pinscreen app is doing. Anyway, some people are already working on that, there's also things like virtual influencers, right? So that are in some ways, propagating on social media using, humans that actually don't really exist. The most famous one is probably Lil Miquela from Broad, and the other one is a new one from Japan. It's less known, but it's interesting that these virtual humans are becoming influencers and connecting with people, right? Another application why virtual humans are essential is because it can solve the communication problem. So imagine right now the only way that we can communicate remotely is through a Skype conversation. We can have a face-to-face conversation, but if we really want to replace a in-person meeting or something we can talk face-to-face, you have to fly there, right? So in order to solve this transportation problem, one way is to do virtual teleportation, which is you put on your VR headset and you can actually see the other person on the other end. The main difficulty here is that, well, you need to digitize the other person, and obviously the other person is wearing this bulky thing on his head. And it's not only in VR, it's the same problem in AR. So in AR, for example, you want to enable remote collaboration on specific problems, but then there is a need to be able to digitize the other person in a very easy way. So to make these things accessible to consumers, we have to develop technologies that can create digital avatars easily. So digital humans is something that people have seen this in many movies, many visual effects. It's something that is known to be very difficult to recreate, especially if you want to go across something that we call the uncanny valley. So this is a work that I've been working on a couple of years ago at Weta Digital, which is we want to recreate digital Paul Walker, but it takes several months to just create a couple of seconds of his own face. Nowadays, we also know that real-time graphics has evolved so much that we can actually generate, have an end-to-end system where we can go from the performance of an actor onto a digital person in real time. So that's possible. You still have a little bit of this uncanniness in there, but then this is something that's already possible, but still creating the asset is extremely difficult, right? So it takes a couple of months to create the assets. You have to rig the character, you have to generate all the textures, you have to wear all these things, so it's not something that is accessible to humans. So that's exactly the type of research that we're conducting in order to solve this problem. So let's start with a face. I'm just going through like a couple of interesting things that we have done. This is the standard way of getting high-end VFX production level virtual faces, is you put a person inside something called, for example, a light stage that we have at ICT. And it's basically controlled lightings, a bunch of cameras that can scan the face at high resolution, very similar to photogrammetry, but you have controlled lighting. But then the problem is this, is a $1 million device. Not everyone can afford this at home, and no one wants to have that. So what we have been working on is developing deep neural networks that are actually trained with data from these type of high-end capture devices that allows you to have a deep neural network generate these type of 3D assets. So what you see on the left, this is a single picture that has been captured using an iPhone picture. And what it allows you to do is actually generate a three-dimensional model with all the pores and also complex reflectance properties. It can imagine how these things look like so that you can actually relight them inside a new virtual environment. Another problem is that most of the pictures that you can find online or whenever you're taking a selfie, in most cases they are unconstrained, right? So what it means is that they have been taken in the wild. The lighting conditions are very, very challenging, and maybe the person is smiling, right? So it's very hard to have a passport type picture. So one of the new things that we've been working on is develop deep neural networks that can somehow predict how someone would look like when the person doesn't have, when someone doesn't have a neutral face. So what you see on the very left, these are some state-of-the-art research results that we've done. This is a arbitrary picture of someone. What we first do is the first pass is turning it into a state where the focal length is canonical. The next one is we're trying to repair the lighting condition. So you can imagine, even in the bottom row, we have a very, very strong contrast. So we're using this deep generative model to actually imagine how the person would be re-illuminated if it was in a diffuse lighting condition. And on the very right, that's basically the ultimate, which is we try to predict how the person would look like when he or she has a neutral face. And this is not only useful for generating avatars. Here's another interesting application. This kid, for example, is a kidnapped child that is posted on the FBI, top most wanted, people. And the only picture that is available is this smiling face. Imagine if you wanted to generate a few artificial images of these people when, under different conditions. What if they were not smiling, so that it would allow people to actually determine them better? Anyway, I'll skip the live demo. You guys can actually download it straight from pinscreen.com. So there's an app called Pinscreen. You can just download it. And what it allows you to do is actually take a picture and generate a 3D avatar, right? And you can do things with it. You can, customize it, change clothing, and it's pretty much like a way to generate a 3D avatar. This is something interesting where we are trying to use it for virtual shopping. So on the left, this is a picture of a woman, and what we're trying to do is we're trying to create these clothings that can be simulated with the avatar underneath. Anyway, this is just for creating static avatars. We have to look into how do we create facial performances as well, because you have to animate in. So that's also something you can actually try on your phone. Something that has been already resolved, and you've probably seen that already, is that all you need is a video camera nowadays to digitize a person's face. So if you wanted to create some animation of that avatar, you can use any standard technique like remapping onto a 3D character, but we want to go beyond the uncanny valley and really solve something that allows people to generate photorealistic content. So what we have developed recently is an algorithm that can generate photorealistic expressions from a single input image. So on the upper right, you can see these are pictures of people where we have only this frontal face. On the left, this is the driver, and everything below has been imagined by the deep neural network. So it can actually imagine what the person is doing. So now you've probably seen in the news what's capabilities you can do if you do that kind of stuff. This is an interesting test. You just need a single. We definitely didn't scan Kim Jong-un in our offices. We just took a picture of him online, and it's real time, right? So if you want to see it for real, you can contact me and I can give you a demo. So the person is sitting in front of the webcam, and it's generating its facial expressions in real time. So, this is something that has been in the news. This is from 2 days ago. U.S. Congress holds the first hearing on deepfakes. Some of our research has been shown, in terms of like face swapping, what can we do in order to detect? So we have a collaboration with Berkeley and DARPA, where we're trying to improve algorithms to detect video manipulated images, right? Okay, so last thing I want to show, we've looked at how do we create faces, how do we bring them to life. There's also the entire human body that we're looking at. So there's something that you probably have seen a lot, photogrammetry. So you put a bunch of cameras around a person, you get this high-end 3D scanner, but again, this is something that is not accessible to people. We want to bring our technology to the masses so that anyone can create content. So we've developed this new, again, it's a deep neural network, that can imagine how 3D scans look like by just looking at a single picture. So that's a picture of me in Sydney, right? So the deep neural network can automatically segment the person out of that picture, and it can imagine what the 3D shape of it looks like. It can also imagine what the back of it looks like, including the texture, right? So this is kind of scary, but what it allows you to do is really create content at scale without requiring to have access to a lot of data. So we took a couple of pictures from fashion catalogs. It's just a front picture, and what it can do is it can generate this three-dimensional model from just that single picture. It does not require hundreds of cameras surrounding the person to do multi-view stereo. And this is something that we're going to release, hopefully not in the near future. So it's going to be a code where everyone can try out and you can test for yourself how it works. Anyway, so our direction is in the field of computer graphics and computer vision, and everything right now nowadays is like based on AI, and AI really means, at least for the near future, things that are based on deep neural networks and deep generative models. What I think is going to happen is that probably at some point you won't have a YouTube that is used to retrieve videos or content, but is a YouTube that allows you to actually generate content, right? Something that things that never existed, and you can specify what you want it to have. There's also the question of, can machines even create art? This is actually a recent work that we've also done that allows a deep neural network to disentangle art styles with the content, right? So this is an example where you have different content that are being generated from a specific style that we have set. So you've probably heard of this thing called, this person does not exist, this anime does not exist. And we can do the other thing. We can say we want the same content, but with different art styles from various artists. All right, so this is to give you a little idea of like what kind of stuff we're doing in terms of digital humans. There's a short-term, low-hanging fruit about virtualizing every person, which leads to the ability to personalize content. And maybe at some point we'll go from, if we can simulate people artificially, maybe we'll go back to the physical space. And in the end, maybe that brings us closer to, connecting with artificial life. So can machines love? Thank you.